Really nice to see so many familiar faces here. And what I would like to do is take you through the process, how I got this whole thing started. So it was 2017 when I first heard about Neil's and Bill's theory, and I read the book in 2017 spring, and then I started to think that it sounded really familiar to me, like a lot of it clicked with me, but I wasn't satisfied with the kind of the social dynamics explanation for the theory, how it would work, so how the cycle would go on and on and on. So I started thinking that if there is some other explanation for the cycles, and the most interesting thing that came to me was how the sorry, my English is a little bit rusty. How the parenting intensity changed over the 8-year period. And for about a half a year, I thought about it really hard. How is it possible that it would go like that? Because it was the same curve here in Finland, and we are so far away from the States. And then I realized, as I was doing schoolwork, that there is a hormone called oxytocin, that if you have lots of it, then it means that your parenting intensity is greater. And I hope that parenting intensity is the right phrase for this. I think everybody understands what I'm talking about. And I'm going to now share my screen so I can better explain what I did next. Let's see. Okay, and can everybody see my screen now? Is it sharing?
Yeah, it's sharing.
Okay. So let's go a little bit forward. So yeah, so oxytocin this is the curve from the Generations book over here, and it shows a really neat curve over 80 years. And then I started to think that how could I find oxytocin levels from the statistics of different countries. And then I realized that there is two things, and they are breastfeeding and maternal age. So you need oxytocin in order to breastfeed. It won't happen if you have low oxytocin levels. So then I started to look for breastfeeding rates, and I found these stats, and they show very clearly. Here is first US stats and Australia stats, Swedish stats, New Zealand, and all over the Western world, and they all go down. The lowest point is right in the beginning of the 1970s. Like there is Sweden, there is New Zealand, you can't see the numbers, but it's in the early 70s when it's at the lowest point. And then there are a few other statistics like Norway and even Japan and UK here. And then I started to think that this doesn't prove anything yet, but then I thought about the maternal age, and all the maternal age, well, like I said previously, when you have a low oxytocin level, you have babies earlier, and that goes for men and women too. So then I started to look for statistics on average age of mothers and fathers, and I found that the statistics are the same as with the breastfeeding statistics, meaning that the lowest point is very low in the year 1970 and really close to it. So here is Britain, Australia, Denmark, and I think this was France. And as you can see, it's always the same thing. In the early 70s, the maternal age is lowest. And it goes in a pretty straight line down. And when it hits the early 70s, after that, it goes again up. And there are, and here's also Canada, for instance. It's really close. It's like 75, I think, the lowest point here. So these statistics correlate really, really closely with the breastfeeding statistics. And same goes for paternal age. So the usual explanation, for example, why women are nowadays so old when they have children is because that they're working. That it's because they have to work, that they have children later on. And I think this is kind of a truth that everybody knows, and everybody says this. Everybody I've talked to about this issue, they all say that it's because women go working nowadays. But it simply can't be true, because here we have the curve of women in the labor force, female labor force participation rate, and it goes, here is from Canada, United Kingdom, and United States, and it starts from the low 20s, and after that it goes up. So here's from the 20th century, these statistics. So it cannot be that women are having children and men are having children at a later age. It cannot be because labor force participation either. So after that, I thought that this is such convincing statistics that the curve, let me go back to it, the curve in the Generations book, that it would actually be an oxytocin curve. So that is the idea here. So the idea is that generations that are born, or birth cohorts that are born in the 1970s, they have low oxytocin levels, and those that are born in the, say, 1990s, early 2000s, they have high oxytocin levels. And then I started thinking that what if other parts of the Strauss-Howe generational cycle could be hormone driven too. As we know that they have said that, for instance, so let's see, it was social priority, for instance. It's always that during the third churning, or at the beginning of this churning, social coherence is low and there is maximum individualism, meaning that the societies are somewhat splintered. And I started thinking about that, and then I found out that, for instance, the levels of dopamine hormone, they control this social coherence in animals. And I thought that it could be true for humans too, that if there are high levels of dopamine, that would mean that the social coherence levels are high, and when there are low levels of dopamine, the social coherence levels are low. meaning that the if the social coherence is truly low in the beginning of the third churning, that would mean that there would be low dopamine levels then. And when the social coherence is getting greater towards the end of the cycle, the fourth turning, then it would mean that the dopamine levels are higher at that point. So I made a curve like this on the screen, but the curve is, it's peaking like the same. So in a way, this would be a dopamine curve you're seeing right now also, maybe a little bit later peaking. And at that moment, I'm sorry, I'm jumping here a little bit. I drew, you can see it here better. So here is the dopamine curve in the blue and the oxytocin curve in the yellow. And the idea is, as you can see, that they all draw the same curve, but they go in different phases here. And I had a little bit better presentation on the laptop, but due to technical difficulties, I have to use my pad to demonstrate these things. And then I also thought, after that, I started to think that obviously if there are differences in the gender gap also, and also Strauss and Howe noted that there are birth rate differences, that birth rates are higher during the first two turnings, and then they are lower during the last two turnings. So that is when I draw the sex hormone curve. And so it peaks around, actually I have that wrong photo here, let's see. So it peaks during the first and second turnings, and then it goes lower during later on. I'm sorry, I have to scroll this a little bit. But the idea, I think you're starting to get the idea that it's that I think that hormone levels, generational hormone levels are what control the differences between generations and how they behave. Trying to find the, let's see. Okay. All right, and then I started to look for proof that the sex hormone curve would really be like the one you can see here. So it would mean that individuals, birth cohorts that were born in the 1940s, they would have high levels of sex hormones, which would mean that they would also have low levels of infertility. And let's see. And here we, for instance, have a statistic that clearly shows that individuals that are born close to 1940, they have really low levels of infertility. And the curves are very highly in sync between different nations. So the infertility goes down from the early 1900s, and after the birth cohorts of the 1940s have been born, then the infertility rates go back up. So this clearly indicates that the highest birth cohort that was born in the 1940s, they have the highest levels of sex hormones. And here we have birth rates, and they clearly also show that the birth cohorts from the 1930s and 40s have the highest fertility rates. And so that is when I drew the sex hormone level, and then it looked like this. So now I have the oxytocin curve and the sex hormone curve and the curve for dopamine, and vasopressin is something that dopamine just controls, so I won't go too much into that. And then there are lots of other things, like I thought about aggression, that aggression is normally highest during the I think it's the switch around from second turning to third turning. And as we can see from the crime statistics, that is the case. Let's see if I can find them also here. So here are the crime rates, and what is very significant is that there is a high degree of correlation between nations. So here we have the United States crime rate. It peaked in about 91. In Canada, it peaked about in 91, 92, and in UK it peaked in about 95, 96. So a high degree of correlation, and the same goes for much of the rest of the Europe, for instance. And there is no other good explanation for this phenomenon, and it has been researched a lot, but it's still a mystery for the researchers. And let's see. And yeah, let's go back to the. And roughly at this point, when I had drawn these graphics that would show there's also growth hormone, but I won't go into that too much either now. In 2019, I found out that, I don't know if others here are that familiar with the animal population cycles, but they go in nature, they go in cycles, like small rodents go in cycles of 4 years, and rabbits in about 10 years, and moose about 40 years. And the cycles go like this. They start with a very high degree of fertility. It goes up, the fertility, just like the sex hormone curve here. So during the first, if we divide their cycle, the small rodent cycle, which is about 4 years, we divide it into 4 years, 4 parts, 4 phases. Their fertility peaks at the middle of the second turning, of the second phase. It goes really high, and then it starts to go down, and after that, the idea is that in the animal population cycles, the reproductive rates first go up during the first 2 phases, and then they go down during the 3rd and 4th phases. And there are other things too, like during the mid-cycle, the aggressive rates go up also in the animal population cycles. And so it's exactly the same thing as in the Strauss-Howe generational theories cycles, that first the reproductive rates go up, and then they go down, and mid-cycle the violence goes up, and it is lower in the beginning and in the ending of the animal population cycles. So there is a high degree of correlation between the animal population cycles and the Strauss-Howe generational theories cycle. And then I thought that it couldn't be just a coincidence. So that is when I started to go and look for if there are studies done on the animal population cycles. And the researchers for over 100 years have thought that the reason for the population cycles are in the environment. But if there is a high degree of correlation between a cycle that is found in human populations and in other animal populations, and it scales between different animal species, then it would make a lot of sense that it is the same cycle. And especially when I found a few studies that have measured these hormonal changes during the different phases, the different 4 phases of the animal animal cycles, I found out that they have the same changes at the same phases of their cycles to the hormone levels that I had presumed to have happened in the human cycle, which is called, which is what Strauss and Howe found and documented in their generational cycle. And I find this highly unlikely that it could be just a coincidence. And I have made further discoveries regarding this. And for instance, one of the discoveries I made just a few weeks ago when I talked with my colleague from law school, and he said that it has been found that in different countries, so it's not country dependent, violent criminals or offenders have low heart rates and low blood pressure. And dopamine is what controls blood pressure. So I had drawn the dopamine cycle in a way. These are the birth cohort levels. But if someone has been born in 1960, and then my presumption is that it takes about 30 years that it shows on the societal level. So which means that in the 1990, according to this curve, the dopamine levels are at the lowest point, which would mean that there is, at that point, there is the crime levels are the highest. And it matches exactly with the curves I've drawn. So meaning that at the beginning of the animal and human cycles, it looks like the dopamine levels are high, which leads to a high level of social coherence. And this has been documented in the animal cycles. And of course, that is also what Strauss and Howe documented in human populations. Then when they go to mid-cycle, in the animal populations, the aggression is highest at that point, and the same goes for the human cycles. And then when we get closer to the end of the cycle, in the animal population cycles and in the Strauss-Howe generational theories cycle, the violence goes down. So what I'm trying to get here is that there is a high degree of correlation between the animal population cycles and the human cycle, so-called human cycle, which is the Strauss-Howe generational theories cycle. And I've yet to find any real disparities between the human cycle and the animal cycle. they're essentially the same. The only thing is what changes is the length. But even still, when the length in years changes, the phases are still the same. It's always the 4 phases, and it's always in the same order. So this is what I've been getting at. And last about 3 months ago, I went to a professor at my university, a professor of evolutionary biology, and I presented this case to him, and he said that it's possible that the animal population cycles are driven by changing hormone levels. And after that, we've been writing an article, and we're planning to probably finish it this summer and try to get it published. So we would gain scientific consensus at some point that it is actually a hormone cycle that drives the animal population cycles. And if we are able to do that, show that it is truly this, as other research from the past indicates very strongly, if we can show that it is that, after that we could show that the same is true for human populations, because mammal species, animal species are highly cyclical. So it would make much sense that a species that is highly social, and I mean they are really close to each other, they have a lot of communication between each other, I mean physical closeness to each other. So I'm obviously talking about humans here, so that species would also be cyclical in the same way as the other animal populations. I think Neil just sent a chat that he would have a few questions. So go ahead, Neil.
Yes, Jan, thank you very much. Oh, there you are. I can see you now. So, well, first of all, Jan, I just want to thank you for tremendous amount of effort over a long period of time. I can't remember when we first communicated, but I think it was some time ago, maybe a couple of years. And you know, it's a very innovative and an imaginative approach, and I'm always in favor of that. And it takes a lot of perseverance to stick with it and try to think through it all. And I think this is all very fruitful. And I think the beginning of looking at a very new way, a new paradigm, is always first to be very sympathetic and to try to understand what are its possibilities, right? I mean, you can always come in and start criticizing this and that, but I think the first thing is to just see, okay, what's possible here? I think we've already talked about some of these, but maybe I'll bring these up for just the benefit of the wider group. And I have three kind of main questions, and I'll bring these up in this order. My first question is cohort shift and age. You often talk about these eras, you know, first, second, third, fourth along the cycle. And I'm never sure quite if you're talking about the entire population or you're talking about something cohort specific, which then later ages with that cohort. In other words, is this like a viral infection, you know, sort of a social infection? In other words, everyone is afflicted by high oxytocin, and then later on, everyone goes down. I mean, that's possible, right? In other words, this could just be a social thing. Or is it that one group has this and ages with it over time? So that's my, you know, I have three big questions, but that's my first one, and I throw that one up to you first. And if so, I mean, when you talk about animal populations, for instance, you're presumably not differentiating between young and old. You're just kind of looking at the behavior of the entire population. So maybe you could just explore that one first. That's kind of my first question.
Yes, and that is obviously the kind of the weakest point still of the hypothesis at the moment. But the reason why I haven't gotten help, so to speak, from the research from the animal population cycles is that almost all of the research has been done on small rodents, and they live usually from 1 to 2 years. So if they lived 4 years, we would know how they would act if some of the voles or lemmings would be born during the first phase, and they still would be alive during the fourth phase. We could take measurements of the hormone levels then, and then we could tell what is the situation there. So the problem is that there is no data from animal populations, but the idea is that I think that clearly in human populations, for instance, the divorce rates of boomers have not really gone down. So I think that at least oxytocin levels are stable from youth to old age, and they don't really kind of they don't change during the turnings in human populations.
Right.
But
Well, and it may be simply that young adults are sort of the new activators of whatever is going on in society. It's where most of the attention is, right?
Yes, that's true. But on the other hand, when you look at birth cohort, birth rates, fertility rates, you see that they go a little bit hand in hand. So when you look at when the birth rate started to go up in, I think, the 1930s, somewhat in the US, for instance, it was the same thing for all of the cohorts or ages from 15 to 45. So,
yeah,
I think that testosterone levels, they are affected by the generation that is most actively having children about ages 25 to 30. So
right.
there's a little disparity, I think, between hormones, but I think that the sex hormone levels are affected a little bit, and dopamine levels are, I'm pretty sure they are affected, but oxytocin levels aren't.
So let me this is fine. I don't want to hog the time, so I want to get off to my other two questions.
Yeah.
But obviously that's one, is sort of how does the whole generational aging angle get into this? My next question, and it's really related, the 2 and 3 are kind of related. You know, in all these kinds of studies, correlation is not causation. You know, that's the old mantra of the social sciences. And you know, when women suddenly have kids earlier, well, you know, so something might have happened in the culture, something might be happening in society. They all have kids young. Well, then therefore they have, you know, low oxytocin levels. They obviously don't have career. In other words, a lot of the other things then would follow from that. I guess the point is that you don't always know whether or not, even if you do observe this, it is the effect or the cause. So this is important because you don't know, is culture coming first? That is to say, you know, humans are rational animals. We have fads, we have social trends, we have ways in which we think. You know, we all know this, right? So this is the question. In other words, is this epiphenomenal or is this causal and driving? This is, by the way, why I think that the animal studies are so important. In fact, because animals don't have a culture. I mean, no, seriously. This is why looking at animals actually is in my opinion, more interesting, strangely enough, than looking at humans. Because humans, you always have this problem of determining whether these cultural trends, wars, awakenings, religion, I mean, all these other things are actually determining these changes, which may actually be going on, but you don't know if it's causal or not. Whereas if you're looking at animals, it's kind of hard to see what else would be going on, right?
Yeah.
Hormones would almost have to be causal, I think, I mean, unless, someone's more in tune with animals than I am. So this is why I actually think that if you were to particularly concentrate on these, because one thing I find fascinating about the animals is generally we think of, diurnal rhythms, annual rhythms, lunar rhythms. I mean, we all know we're subject to these, but you seem to be finding longer rhythms that are not driven by environmental conditions like scarcity. As I recall, some of your studies actually looked at scarcity as a driver and actually ruled that out. I think in rabbit studies, for instance, they actually made sure that starvation or lack of food was not an issue. I found that really fascinating, and the fact that I think you once had a study of moose, and I think the moose has lived like, I don't know what the plural of moose is, so even my English is limited. But anyway, many mooses that they live, I don't know where they live 18, 19 years, right? And or they live longer, and they have much longer cycles. So that seems extremely promising. Believe it or not, I realize that it's actually more removed from human populations, but because it removes this causal issue, to me, it's actually, oddly enough, kind of more interesting.
Yeah, that's true. Did you have a question there?
Yeah, it's kind of, my question is whether you plan to look more at these non-human, kind of these mammalian longer cycles, particularly in longer-lived mammals. Any work like that you could draw light to or find, I think would be particularly fascinating for the whole plausibility, sort of the plausibility of the underlying mechanics of something like this.
Yeah. So I would first go back to your notion that it would be social change or whatever happens in a society that would change these trends in birth rates and things like that. In the statistics, it shows that pretty much only World War II, it made kind of glitches in the otherwise kind of smooth curves. There, it goes like this, and then there's World War II. It goes a little bit this, but the trend continues. So even a huge event like that, it couldn't change the directions of the curves. It only made a dent in the curves. So and as for birth rates, there is such a high degree of correlation in both fertility rates and in the infertility rates. And it's I just can't understand how it could be that all over Western world the fertility rates would go such highly in sync, because there was much more cultural differences and societal differences before the age of television, for example, after which the cultures have merged more. But the statistics are so highly correlating, and once again they are also correlating with the animal cycles, that it's kind of hard to find anything that would make them correlate so much between different nations.
Well, I actually did recently a review of this. I can't remember the book, but it's there's a lot of attention now being drawn to sort of endocrine imitators in our environment, which may be driving down fertility, throughout all developed nations over the last few decades. And in other words, you need more than an N size of 1 to test that, right? I mean, you'd have to go back and look at earlier cycles, and we just don't have very good infertility data on earlier cycles. At least I haven't found it. If you just look at fertility rates, that's demography is my thing. And I've looked at those for almost every country over many centuries. And in America, for example, before post World War II, I mean, it was always declining at various speeds. So there's not a lot of interest there. You could talk about certain decades when it kind of evened out a little bit more. You can talk, you know, there are interesting things you can say, but it doesn't exactly jump off the page at you. I'm just simply saying, obviously, times of war, times of peace, times of prosperity, these could obviously be drivers. That's all I'm saying. I mean, there are obviously explanations that could go the other way causally. And just to repeat my point, that's why animals interest me so much, because, you know, presumably they don't have that kind of complexity of causation.
Yes, that's very true. That's very true. And there are obviously much more things that I found out about oxytocin and dopamine, and which are in the hypothesis, and they all kind of imply that when those social hormone levels go higher, then people start to gather in groups, and group coherence increases. And there are studies done on humans, obviously, where people get shots of oxytocin and they become more kind of racist. And by racist, I mean that they want to preserve their own kind more, and they don't care as much about the other groups, the people who belong in other groups. So I'm not only providing, obviously, statistical, and you obviously know this, but I'm telling to everyone else listening that it points to the fact that these social hormone levels, when they go high, we see societal change like we see today, that groups become polarized and start fighting each other. So there's not just statistical evidence, that there is also clear evidence that these hormones cause the things that you have documented in your theory. So and once again, the same things happen in the animal population cycles. So it's the strangest thing, I think, is that the animal populations show the same kind of behavioral changes in each of the 4 phases, and the changes are the same in your theory, and it's always the same order, and they are always accompanied by the same physical and behavioral changes that match the hormone level, that changes to the hormone levels. So it's if you kind of how would you say it, take out all the speculation how other humans affect other humans, and just leave the hormonal behavioral cycles that I have drawn, then they highly match with the animal population cycles. So
right,
that's like my strongest point here, and I've yet to hear from anyone that would disagree with this notion.
do you have any speculation on the timing of these animal cycles relative to their average period of sort of gestation, or, you know, between birth to reproduction? In other words, these cycles are obviously faster for the shortest lived of these mammals?
You mean what determines the length of the cycle for the?
Well, yeah, just the relationship between each mammal, because as I recall, there were several different mammals, all with various different lifespans. I was just curious as to whether you thought about it all.
Yeah,
the timing.
I think, because speculation, if it would be the same cycle for humans and other animal populations, I would say that it's the developmental stage, because humans reach kind of full sexual maturity at about 18 to 20 years, like full. So
Right.
I think it would have to do something with that. And on the other hand, with the rodents, it seems like 4 is the minimum. So for them, it could be like 2 years, but then they couldn't accomplish the whole cycle, all the phases of the hormone cycle. So
Well, and unless they were to live to old age, we'd have to give them metformin and rapamycin and just get them to live longer, right? So,
yeah.
Okay, understood. Well, thank you very much, and please others should feel free to ask questions.
Well, we have Steve with a question. Steve, do you mind voicing yours?
Yeah, my first question that I asked on the chat was where would one go to find data on hormone levels, you know, in the past, right? You have this great hypothesis, but to test it, we would want to measure hormone levels in, you know, in people in the past to correlate it to these cycles. Where could one go to find such data?
There is no such data, and because, for instance, oxytocin molecules are so small that we are still having difficulties locating them in the bloodstream. But I think the correlating data, or the breastfeeding rates and maternal paternal age and other statistical evidence, it's much more important because it shows on a population level how the hormones are available to individuals. And there is the problem that the hormones are secreted from the brain, and we still don't have good enough imaging devices that we could see from live persons the secretion rates. So it probably will take 10 or 20 years that we get so far that we can really see how fast the hormones are coming. And but still, I think it's much better and more accurate data if you look at the historical statistics of certain behavioral traits from humans, like crime rates, breastfeeding rates, like that. So it shows how the hormone levels are in societies.
So since we know that those hormone levels correlate to these behaviors, we can use these behaviors as proxies, is what I'm understanding.
Yes, that is proxy statistics, yeah. That's it.
Narotama, you have a question about social signals.
Well, I heard Neil say that the scarcity was ruled out, so that answers my question. I guess I could just take this opportunity to, you know, I was born '81, I was a millennial. Thank you, Neil, for keying that term. And I was horrified to see that we had been renamed Zennial. You know, I guess the best of both worlds, right? We have a little bit of tech savvy of the millennials and a little bit of the extra spirit. And I would just, I'm just going to continue my campaign on naming it Malexer. Neil, if you can remedy that horrible mistake and name that cusper the Malexer, we'd be greatly indebted. Thank you.
I'll take that. Let's get rid of Zennial. All right. So, what? I'm sorry.
Yeah. No. Go ahead.
So we have Chaz. Hormones on a cycle, or on a cycle.
Thank you, Ryan. If hormones are on a cycle, what does medicine advertising that you can change your levels of hormones do with regards to its effects on this cycle?
I didn't quite hear your question. Did you say that? Did you mean that does medicine in general, could it affect hormone levels?
Correct, because there's always seems to be advertisement, as long as I can remember, saying, "Oh, your depression is because of these hormone levels not being balanced. If you take our medicine, we can rebalance them for you." And that sort of stuff. How would that affect this cycle?
Okay, so as a very general answer, I would say that individual differences due to something like that would even out totally on a population level. And I don't think that there is, even if a lot of people take medication for depression or anxiety or something like that, we still don't know how it, on the long term, how it affects the hormone levels. But I don't think it really changes the hormone secretion from the brain too much. So it could be I strongly believe it is temporal, and the same thing goes for foods like soy. There's a lot of talk about soy boys and stuff like that, and people think that men aren't men anymore because of soy, but in reality, soy changes it one's testosterone levels for like maybe 15 minutes, and then it goes back. So there is no permanent change at all.
Eileen has a question on the social order. Social order changes. Eileen, do you want to voice that, or Steve?
I think this actually been discussed. The question was to the effect of, could these external factors caused by like a cycle that's socially driven be themselves causing the hormone changes? And I think Neil addressed that already, that the hormones could be the epiphenomenon of something that has a different level. Does that make sense?
Okay.
Yeah, it does, but I don't know of any research that would validate that notion that hormone levels are somehow permanently changed by social change or anything else that happens. And actually, I did this kind of theoretical curve. I think it was in 2018, 19, around then, before I found the animal population cycles and the hormone changes, the hormone fluctuations in them. I thought that maybe epigenetics could change hormone levels from generation to generation, and this could explain, for instance, the oxytocin cycle, but it's simply impossible. And if it's impossible that way, then it also is impossible for social change to change hormone levels permanently. So it's kind of a beautiful thought, and I had that too earlier, but it just doesn't work.
Okay, Phil, you're up. You have a couple of questions.
Yeah. First off, because I approach the theory, I think, a little bit differently. I think that I tend to think that the turning system works because it's just how human beings tell stories, that, over time, it just repeats itself because this is how a story goes. And that it's not necessarily causative, it's just that these are the stories that we tell as human beings. So when I'm looking at something like these hormone levels, and we don't necessarily know how social animals are. For example, raccoons are highly social animals. We just don't know what they're saying because,
That's true.
they're raccoons. Same thing with cats, dogs, highly social animals. Do we have any data on unsocial animals? Something like an octopus that doesn't like to usually interact with other octopuses and will fight each other off. And that's the extent of their social interaction.
Not really. The data from the cyclical animal populations is, like I said, from small rodents and rabbits and then moose, and that's pretty much it. As for the hormone levels, so I don't know of any kind of, well, on the other hand, the rabbits are, they can be like really long distances from each other. So they aren't very social when you compare, for instance, to the wolves and lemmings. But it seems that even they have the same cycle, even though they're much less social, and especially they have much smaller groups where they live in the forest. So, and still there are no real differences between the highly social species and the less social species.
Okay, and then my other question, it kind of bounces off what Chaz said, but people who, and it's, you know, probably going to come up more as a issue as we kind of get more into biology, but, you know, people who do permanently alter their hormones by taking regular injections of hormones or regular hormone treatments, is there kind of an opportunity in there where people would choose to break the cycle?
What do you mean an opportunity? Do you mean that everybody could start taking hormones, or?
Right, like, I mean, you're linking, let's say, criminality with,
yeah,
you know, a hormone.
Yeah.
And I could see society deciding, hey,
Yes.
criminality is bad. We need to get rid of it as much as possible. Let's just all get on this hormone and try to eliminate crime.
Yeah.
Meanwhile, you break the cycle. And
Yeah.
what does that mean? Like, could you break the cycle by a hormone therapy? And if you did, you know, because I take it from a storytelling perspective. So does that end the story? Do people have to find a new way to tell stories as a result?
Yes, I think you're right. If it is true that, for instance, low dopamine levels, like it looks like very strongly, and actually I could tell that also when you look at the crime rates, the daily crime rates, let's see how I can, if I start here, no, like from here. So here is 6 a.m. and then crime rates go up until about midnight, and then they go down again. So when I looked at daily dopamine levels, it's the same thing. They start from the high point, and low dopamine level means more crime. That's the presumption, at least. So the dopamine levels start high in the morning, people feel alert, then they go down, and until midnight, and during the night they go once again up during the sleep. So there is even daily correlation. So what I'm getting at here is that, yes, I think that if we would level out the dopamine levels, so mid-cycle, those that have low dopamine levels, they would get dopamine injections or some kind of a chip or something that would make their dopamine levels higher. I believe that crime would come down. And on the other hand, when presumably the dopamine levels are high at the end of the cycle during the fourth turning, the fourth phase, if you lower the dopamine levels, I think we would get rid of these polarizations between all of the groups. We can see it between nations, between parties, between genders, between pretty much anything. If there is any kind of click, we get polarization. And I believe that if the presumably high dopamine levels of today would go down, we would see much more easygoing life in the Western nations.
But like, how would we get things done? I mean, I mean, seriously, like.
I mean, just level them off. Put them kind of in the 50% stage. But there's also the philosophical question that you asked. That would we break the cycle? that's a good question. Would we want to break the cycle? If it is this hormone cycle, the same, if it is the same cycle that's Strauss and Howe found, then it's a very good question. Would we kind of slow down progress or something? I don't know. It's a good question. So are there more questions?
Yeah, I have another question, Jan, if you're game. You mentioned epigenetics and your decision that you aren't impressed with that as a causal mechanism. So let me go back to these mammal studies again. So if it's not the environment, and presumably it's not changing upbringing unless we have, periodic moral panics about raising children among raccoons or something. And it's not epigenetics, that is to say something involving, methylation of certain parts of the DNA, all of the kind of various, and we know very little, by the way, about epigenetics. We don't really know entirely how it works. We do know that we see it in humans who have been through famines, trauma, definite signs of genetic changes, or at least the expressions of genes. Why are you so quick to eliminate that? And if you do eliminate that, what else is left to be causing that in animals? I mean, You've eliminated nature, you've eliminated nurture. So please, the floor is yours.
Thank you for the challenge. So let me start by saying that there is no study, to my knowledge, that would show that epigenetic changes would cause hormone levels to change over 15% in any situation on the offspring. So there are some epigenetic changes, but they are very small. So, and when you look at the fertility rates and the presumable oxytocin rates and stuff like that, there are huge changes. The rates go from 80% to 30%, and then back to 80%. So there's about a 50% change, and the even more, what is even more important from the animal populations is that you can have animal populations like rabbit populations that are 1,000 miles apart, and still they go in the same phases of the cycle. And there can be a lot of populations and all of them are in sync. And obviously if you have 1,000 miles difference, the environment is completely different here, and environment is what obviously drives epigenetic changes in animals and also in humans. So there is a lot of evidence that shows that environment cannot be the driving force of these cycles. So and I tried for over 6 months to make a really convincing case that epigenetics would be the driving force behind the oxytocin cycle, but it's just impossible. It just doesn't work. And different species have different things that they react to, and stress is the thing that makes the methylations and other things that make up the epigenetic changes. So it's I don't know how else to put it, but it's just impossible.
Well, if I get back again, if it's not the environment and it's not genetics, then what's left? And now, have any of the authors speculated, the people who've written these papers, did they ever speculate on what that might be? I mean, and I would just add, with regard to epigenetics, the absence of evidence is not evidence of absence.
Yeah.
We don't really know about entirely all that much about epigenetics yet. But I'm just saying, if you have nothing else left, you presume there has to be some causation if you're actually seeing patterns.
Yeah, and I've been working on this for the past about 3 months. So at the moment, I think this whole cycle is an evolutionary mechanism that, for instance, creates new subspecies and new species, because probably most here, if not everybody, knows that, for instance, lemmings, they when it comes to the mid-cycle, they start moving really fast, and really many individuals start moving to other populations. And when you think about let's say there are like 4 populations like this, and when they're in sync, like they most of the time are, it means that mid-cycle they start to mingle with each other. And if there is a spot where there is no population, they can also create a new population, and then they can create new populations. And a speciation is it's a speciation mechanism in my mind, because when it creates new populations, they go to new environments, and through environmental effects, there are new traits being developed by natural selection and other also epigenetics. So what I mean, when you go far away enough, then there is speciation, because they just change so much from the original populations. But what is also important to note is that when there's kind of these bridges between the populations, if there is a new population over here and they create a new trait because the environment is different from these other populations, they can transform the trait when it comes to mid-cycle. They can transform it back to this population, and this population can then, if it's a viable trait, they can, in the next cycle, they can go here, the trait goes here, and then natural selection takes care of the rest. So new traits are created in new populations, and then they can be transferred to the old populations.
Well, yeah, I mean, that would explain the utility of having a cycle.
Yes.
You know, you get genetic mixing.
Yes.
That does not explain what causes the cycle. You've sort of finessed the question here.
Yeah, well, I don't know what causes the, let's see, what other cycles we have. Well, we have the life cycle of humans. We have the hormonal changes in different phases of life. What causes that? And we have the menstrual cycle. What causes that? So what I'm saying is that these are mechanisms, hormonal mechanisms, that are based in time, and they advance evolution, because they kind of force the, if you think about the different phases in human life, there are hormonal stages, clear hormonal stages.
I totally get all that, but if it's going to be something that's longer than the lifespan, if it's working through an entire population over a longer period than, you know, the birth to reproductive cycle, it has to work in some way through different environment for the young, or through some genetic change. Otherwise, I don't know how you would change an entire population, right? You're sort of locked out of any alternative explanation.
Yeah, it's difficult to suggest what the mechanism could be, but I still believe it's we still don't know what drives ultimately the menstrual cycle, for example. So I believe it's a similar mechanism to the menstrual cycle and other hormonal changes that are based on counting time from the sun, and or as a biological organism ages. and goes through different phases of life. So I can't give a better explanation here yet.
Okay.
Okay, so it looks like Amy has a question. Go ahead, Amy.
Okay, well, this is a two-part question, I guess, kind of. Okay, so I don't have the data on peaking crime and violence in the theory cycles or in the hormonal cycle. So I guess this is a general question for both you and Neil. Do we see in these cycles where crime increases always at the same point in the cycle? I guess that's number one. Because the chart, I believe, that you showed had it in the 90s, and I always thought that it peaked in the 70s and 80s and went down, and we've been on a downward trend since then. So perhaps I'm wrong about that. So that's the first part of the question. And then the second part is, in the animal populations, when you're looking at these cycles, do they have increased aggressive behaviors at the same point in their cycle as we do in the 4-turning cycle?
Yes, it's mid-cycle, right where the transition is from the second phase to the third phase. And it's obviously in the animal cycles, it's always there. As for human populations, I'm sure Neil has better information on this, but it's
it's mid-cycle. I mean, you're right. So typically, risk-taking, criminal behavior, rule breaking, and so on goes up toward the end of an awakening, is high during a third turning, and usually goes down when you're into a fourth turning. Now that varies a little bit. I mean, there's not a strict schedule. For example, you're right. In the 1990s, well before the any fourth turning in America, crime went down, right? Toward you'd have to say sort of, I don't know, midway through a third turning, whereas the last time it stayed high through the 20s and actually briefly, raged in the very early 1930s at the worst of the Great Depression. In fact, that's when all those famous gangsters were basically captured or shot by G-men, and then suddenly it went way down, right? So throughout most of the 30s, you had a very dramatic drop in crime, which really lasted well into the 40s and 50s before it started rising again toward the late 50s. So again, this isn't lockstep, right? These are associations, and these are complex changes, which don't always occur according to an exact calendar.
Jan, did you have a response?
No, not really.
Phil?
Yeah, I was just wanting to talk a little bit more about the crime thing because I have a degree in it. And when I went to school for this, the crime rate, when you looked at it in the 80s, it was declining in most places. Where it was picking up are places that we highly associate with the drug war. And so that's one of the weird things when you talk about these rates and you have these boundaries like nations. That's a huge population, and what you don't see is what's going on, what's driving those numbers. It's kind of like what I think Neil's getting at with the hormone levels. It's this, when you look at an overall rate, it's very hard to determine a mechanism because you don't have anything to compare from. You're just like, this is the numbers. But when researchers have gone into the 80s, whereas in the 70s, it was kind of evenly spread all over the place, just high crime. And then you get into the 80s and it starts to recede most places, but it spikes huge in communities that were most affected by the drug war. In a similar study, and it's one where we don't know the cause. There was suicide studies done in the 2000s and they went through and combed through everything by locality, and comparing apples to apples, they found that the number one correlative with suicide was the altitude you were living at, which is a very weird kind of thing to happen, and they don't know why it is. But yeah, the higher you live, the more likely you are to commit suicide.
Okay, so yeah, that sounds that it could affect your metabolism or something like that. But going back to the crime rates, I don't remember. I think I was talking about World War II and the fertility rates and breastfeeding rates, and I told that they would go like this, pretty straight, and there would be a little blip, but they would still continue and then start to go down at some point. And I don't know, I can't share my screen right now, but if I show from my cell phone, you can see that there is a clear trend in the crime upward, and then it goes down after that. And the same thing is very clear in different countries. There are a little bit, this is Canada, there is a little bit change during the different phases, but it's very clear when it hits the high spot, then it comes straight down in every country. And there is no explanation for this part here. Why it doesn't go like stay high and do something else? In every country it goes up and then it goes down. And it's and like I said, it's a mystery to people who have been researching this thing, and there is no explanation why it went up and then so suddenly why it comes down, and almost at the same time in different countries. So it's it's the same thing with the breastfeeding rate, for example. So there's no explanation why they go up and why they go down. They just do it. So let's just say that I've been losing faith in sociology during these 3 years a lot, because nobody can provide good explanations.
Chaz, do you have a comment to share? Okay. All right. Anyone else? All right. I'm going to make a YouTube video of this and share it with everyone. I guess I'll give it to you, Jan, and then you could pass it along to everyone. But yeah, thank you for this opportunity. Thank you for presenting this to our group. Neil, I don't know if you know, on Facebook, we have a little Facebook group, 4T Friends. So a lot of the people on this chat, we argue with each other every day, pretty much. So it's a pleasure to have you with us and to see you face to face.
Well, it's a pleasure to be here. I think Jim just told me about it this morning, I think. I just talked with him on the phone. So, I always enjoy talking with people who are just deeply engaged, and it's great. It's wonderful. Look, a lot of this social data is very complex. I mean, crime is a great example, right? And I think the earlier comment is right. I mean, the underlying phenomena of criminality is probably a very deep one that's almost impossible to measure accurately throughout society. The one I usually track in the United States is the victimization survey. It doesn't depend on police records. It's a survey of all Americans. And it's been done since 1973. But if you want to go further back, the quality of your data deteriorates. You want to compare with other countries? Well, they're using different standards, different measures. Every objective set of numbers is partial, right? So that's just one of the problems you deal with here. Presumably, if there is some underlying trend that you're really trying to measure, it remains unmeasurable. And all these other things are, to use the word introduced earlier, proxies, right? They're proxies for something that you're really trying to see. And that's what anyone involved in social psychology is stuck with. You know, you're just dealing with all these proxies, but you're trying to triangulate, right? You're trying to triangulate through all these things, just get a sense of something underlying that's going on. So I think we're all trying to do that as best we can. And I'm very happy to find out about all you guys, you know, grappling with that, dealing with that. So anyway, it's a pleasure to be here.
Thank you. We met, a lot of us met, or I would say I met this group about 10 years ago, 2010, at the old forum, the old forum. And so
yeah, recall it well.
That aren't even in this chat. So maybe we could do this again. And thank you for bringing us together, huh, Jan? I'm going to say your name right one day.
Thanks.
All righty. So I'll upload this to YouTube and everyone will have it.
Great.
Thank you.
Thanks again, guys.
Thank you very much.
Thanks a lot.